you took a vitamin this morning. Maybe you didn't think about it. Maybe you just swallowed it and moved on with your day. But somewhere in the back of your mind, you were making a bet. A bet that a small pill could buy you a little more time. You are not alone in that bet. Humans have been making it for thousands of years. But the real answer to whether it ever pays off is far stranger than you think. Your body is rebuilding itself right now. Skin cells flake off and regenerate. Blood cells are born and die by the millions every second. Your gut lining replaces itself every few days. So if your body is constantly renewing itself, why do you still get old? Why doesn't this endless cycle of repair just keep you young forever? The answer starts with something tiny. Something living inside almost every cell in your body. They're called telomeres. Think of them as the plastic tips on the ends of shoelaces. Except instead of protecting fabric, they protect the ends of your DNA strands. Every time a cell divides, those tips get a little shorter. Eventually, they get so short the cell can't divide safely anymore. It either dies or goes dormant. Multiply that by trillions of cells over decades, and you have aging. In 2009, 3 scientists won the Nobel Prize for figuring this out. Elizabeth Blackburn, Carol Greider, and Jack Szostak discovered an enzyme called telomerase that can actually rebuild those shortened tips. It sounds like a fountain of youth hiding inside your own cells. So why doesn't your body just use it all the time? Here's the twist. Cells that use telomerase without limit don't stay young. They become cancerous. Unlimited division is exactly what cancer is. Your body shortens its own telomeres on purpose. It is a safety switch, not a flaw. Aging, in a strange way, might be the price your body pays to keep you from growing a tumor every time you skin your knee. This is where the story gets even stranger. Not every living thing plays by these rules. There's a small pink animal called the naked mole rat that barely ages at all. It can live past 30 years, which is absurdly long for a rodent its size. Researchers like Vera Gorbunova at the University of Rochester have studied these creatures for years. Naked mole rats almost never get cancer. Their cells have a backup defense system that most mammals don't have. They essentially short-circuit the trade-off your body is forced to make. Then there's the immortal jellyfish, Turritopsis dohrnii. When it's injured or starving, instead of dying, it can revert its adult cells back into an earlier stage of life and start its life cycle over. Biologically, it can do this again and again. Scientists still don't fully understand the genetic switch that allows it. But here's the catch. Being biologically immortal doesn't mean being unkillable. A predator can still eat it. A storm can still crush it. Immortality at the cellular level doesn't protect you from the outside world. So what about you? What about humans? In Okinawa, Japan, and in Sardinia, Italy, researchers have spent decades studying communities where people regularly live past 100. These are sometimes called blue zones, a term popularized by researcher Dan Buettner working with the National Geographic Society. The people there don't have some secret genetic mutation that stops aging. What they share is diet, movement, social connection, and low chronic stress. Their telomeres still shorten. Their cells still divide and decline. But something about their daily life slows the rate at which the damage builds up. This tells you something important. Aging isn't one single switch waiting to be flipped off. It's closer to a slow accumulation of small damages, like rust building on metal over years instead of all at once. Scientists have identified several of these damages. DNA mutations pile up over a lifetime. Proteins misfold and clump together instead of doing their job. Cells stop dividing but refuse to die, lingering as what researchers call senescent cells, quietly releasing inflammation into your tissue. Mitochondria, the energy factories inside your cells, get less efficient. None of these alone causes aging. Together, they are aging. This is why modern longevity research doesn't chase one magic cure anymore. Instead, labs are trying to clear out those senescent cells, the ones lingering and causing inflammation. Other researchers are testing drugs like rapamycin and metformin, originally designed for organ transplants and diabetes, to see if they can slow these processes down in otherwise healthy people. Early animal studies have shown lifespan extension. Human trials are still ongoing, and the results so far are promising but nowhere near a cure. So could you, someday, Actually become immortal? Probably not in the way movies imagine it. No single pill is going to stop time. But the gap between growing old the way your grandparents did and growing old much slower, with more good years, is shrinking. Some scientists believe the first person who will live to 150 has already been born. Others think that number is wildly optimistic. The truth is, nobody fully knows yet. What is becoming clear is this. Aging was never some fixed, unchangeable law of nature, like gravity. It's closer to a setting your biology defaults to, shaped by millions of years of evolution prioritizing reproduction over longevity. Evolution doesn't care if you live to be 90. It only cares that you survived long enough to pass on your genes. Everything after that point was, biologically speaking, never the priority. That's the strange part. You were never built to last forever. You were built to last just long enough. And maybe that changes how you think about the vitamin you took this morning. It's not really a bet against death. It's a small vote for more good years. More mornings. More time with the people who matter to you. The science of aging isn't really about cheating death. It's about understanding the rust before it spreads, and slowing it down wherever you can. You took a vitamin this morning. It won't make you immortal. But somewhere in your cells, in the quiet, constant work of repair and renewal happening without your permission, you are already fighting a battle that has been running since the very first life on Earth. And for now, that fight is the closest thing to immortality you have.